Okay, so hi everyone, Senan this side, and in this video we are going to see how to solve this N-Ary tree post-order traversal. So before you watch this video, a prerequisite is to watch my previous video on binary tree post-order traversal, because the explanation of what I am going to do here is given there, and it's just yesterday's daily problem. So I would link that video in the description, or if you know how to solve them, you could definitely go ahead and watch this video, but the previous video is a prerequisite. So anyways, given the root of an N-Ary tree, return the post order traversal of its nodes values. And yep, the last video's audio quality is a bit suffering, so please keep that in mind. So anyways, the N-Ary tree input serialization is represented in the level order traversal. Each group of children is separated by the null values. Okay, so that is not that important. So recursive solution is trivial, and that's what we are going to look at the very first. So this is my recursive solution. So basically I create a vector int basically a vector int for my answer, and I do the traversal and I store all the values in the answer. If you see, I've passed this by reference, right? And in the end I would return this answer. Now let's look how do we actually do the traversal, right? So I say if root is null, just return. Like for example, if you see null here and here, so if it is null, you just return. There's nothing for you to do. Otherwise, what you do is you take all the children of this node and first process them. That is what is post order traversal, right? First you process the children, then the node itself. In this example, if you see, one is the root node, right? So it would be processed when you have processed all the children of this one. So 1 would be at the end of the list. Similarly, if you look at this subtree 3, 5 and 6, 3 is the root of this subtree. That means 3 would be processed in the end. If you see 5, 6 and 3 among this subtree, 3 is again at the end. And the single nodes in itself is the root. There are no children, so you directly process them. Now what you do is, after you traverse the children, you just process the root itself and you push back the value in the root as a part of your answer, and that is going to work pretty fine. Now, but could you do it iteratively? And the answer to that is yes. Exactly as I did it in my previous video, the solution is exactly the same. Maybe the class structure is different, right? We have a list of children rather than node left and node right. So otherwise, in the last video we did not use a property of binary trees itself, right? To solve that problem, we used the properties of tree, not the binary tree itself. So that is why the solution that is used there is going to work here as well. Now let's look at the iterative solution. So first of all, if the root is null, I return an empty list because there's nothing to do, right? Now what I do is basically I create an answer array and I use a to-stack approach. So what I do is, till the stack 1 is not empty, I take out the topmost element, right? I take out the topmost element, I pop that from this stack 1 and push that in stack 2. Now in stack 1 I push all the children of this top node, right? And I push that, and I do this till the stack 1 is not empty. And after that, what I do, my answer would be stored in stack 2 in the reverse order. So I just pop the values in stack 2 and take that as a part of my answer, and I just pop that element, and that is the solution. And I just return the answer. So this is what we exactly did in this binary tree version as well. So if you see, pretty much accepted. See, it's also accepted both the iterative and the recursive solution. So yep, that was the whole video all about. Hope I was able to explain you. I know I did not explain much because I had already solved this in my yesterday's LeetCode daily problem. So I assume that you would watch that before watching this, and anyway, you watched it till the end. Thank you very much, and I'll see you in the next video.